today I shall be your physics teacher, and we shall be looking at the topic liquid at rest. Now, you all know what a liquid is, and we also know that a liquid is one of the states of matter, and it has molecules too, right? So under this liquid at rest, we shall be considering a very important topic that is called the density and upthrust. Now, the first thing is to talk about density. What is density? I remember when I was taking you on fundamental and derived quantities, we measure this particular word, density, as one of the derived quantities, right? So we want to study density in details today and see how it is applicable to the states of matter. The first thing we should ask ourselves before we go into the topic proper is, what is density? Now, by definition, density is the ratio of mass to volume of an object. So the ratio of mass to the volume of an object is called the density of that object. And mathematically, we can say density, which is represented as rho, is equals to what? Mass over volume. Also, you should understand that the mass is measured in kilogram, while the volume is measured in meter cube, so that the unit of density is kilogram per meter cube. So that's the unit of density. And remember that it's the ratio of mass to the volume of the body. And also, I need you to understand that density is a scalar quantity because it has only magnitude but without direction. Now, the first thing we want to consider here is the density of a solid. How do you calculate the density of a solid aside the usage of this formula? Take for instance, if we have a solid, how do we get the density? Now, before we go over to that, I would like you to understand that there are two categories of solid we'll be talking about here. The first category is the regular solid. Now, regular solids are solids with specific dimensions. That is what you can use for measuring this. Now, with this, I think we have come to the end of the explanation of relative density. The next thing we want to consider now is what is called the Archimedes principle. This principle was stated by a physicist that is called Archimedes, and a question on this came out Jamb 1980. You go search for that as soon as we prove the various formulas using this principle. Now, the question is, what does Archimedes principle state? It states that when a body is partially or totally immersed in a fluid, in this instance, we talk about liquid because when we talk about fluid, it can be a gas too. Fluid means liquid or gases, right? So when a body is partially or totally immersed in a fluid, the upthrust, I told you right from time that the upthrust is the upward force, is equal to the weight of the fluid displaced. Right? That is when a body is partially or totally immersed in a fluid, the upthrust on it is equal to the weight of the fluid displaced. Now let's assume we have, this is your well, or this is a bucket of water. Let me use a bucket of water here, right? Then we have this filled to this brim Then we have the bucket you're using to fetch the water. Let's assume it's from a very deep well, right? And this is the rope linking the bucket to you here. This is you here fetching water, right? Now I realize that there are two forces acting on this bucket. A force is acting downward, which is your weight or the weight of the bucket, that's mg. And there is a reaction acting upward, and that reaction is what is called the upthrust, right? Now the tension is going this way, and for that reason the tension plus the upthrust will give you what? Weight. That is the sum of the upward forces will give you the sum of the downward